Hello everyone, today I'm solving Leetcode question 712. Minimum ASCII delete sum for two strings. Given two strings S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. In example 1, first string equals C, the second string equals EAT, and then output is 231. Explanation: deleting S from C adds the ASCII value of S115 to the sum. Delete T from it as 116 to the sum. 116 to the sum. At the end, both strings are equal, and then the total sum is the 115 plus 116. That's the minimum sum possible to achieve this. In the second example, S1 equals delete, S2 equals delete. Deleting DEE from delete to turn the string into LET. So that's the sum is the ASCII value number for those three characters, and then we delete E from lead. So in the end, both strings are equal, and then both strings are converted into LET. The answer is 403. If instead, there are multiple ways to convert and make the two strings the same, but if for other operations we would get answers that are higher than converting them both to LET. And our goal is to return the lowest ASCII sum of the deleted characters. So this problem is very similar to another Leetcode problem. So that the delete operations for two strings. So I also have a video recording for solving that problem. You can first check that. For this one, the complexity added is to, in addition to the delete operation, we want to get the lowest ASCII sum. So in Python, to get the ASCII sum for a character, get the ASCII value for a character is using ORD operation. So basically, ORD call for that character, it will return the ASCII value for that character. So by calling ORD for the character C, it will return the ASCII value of character C. So my idea of solving it is still using the recursive approach with the memoization. So first, let me define a cache, and then define a helper function to break down this one to solve problem. IJ. This one, what does this helper function do? It returns the minimum ASCII sum for S1 I and S2 J. And then first we consider the base case. If I greater than or equal to less S1, in that case, we just return ORD we return this sum ORD x for x in S2 J. Similarly, if J is greater than or equal to the length of S2, we return this one for S1 I. So that's our base case. And then we check if I, J, not in cache. In that case, we need to compare if S1 I equal to S2J. If they are equal, make hash ij just equal to helper I plus 1, j plus 1. Else, make hash ij just equal to 1 plus not really 1. The minimum of helper I plus 1 j plus ORD S1 I, and then helper I j plus 1 plus ORD S2 j. So in this case, we delete the character at index I from S1. So in that case, for this delete operation, we need to record the ASCII value for this character and then add that to the calculation. And then the second half is, this case, we delete character J from S2. After we delete character J from S2, we need to add the ASCII value for that deleted character. And then we also need to move on and consider the character at position J plus 1, starting at position J plus 1 in S2, because we already deleted a character at index J in S2. But we haven't really considered or match or compare with the character at index I in S1. So that's kind of our recursive step. And then in the end, we just return cache ij. And then we call the helper 0, 0. So let's run the code. Yeah, so this solution is very similar to the delete operations from two strings in Leetcode. I have a video for that one, but this one is just a variation by adding, and we need to calculate the ASCII sum. So for each character deleted, we need to get the corresponding ASCII number and then added that to our result.